Good day, everyone. We are the Group 5, and today we will be presenting our research study entitled Energy Efficient Manufacturing Practices in Mechanical Engineering from 2000 to 2025. Here are my group members: our group leader, Marcos Castro, Patricia Domagio, Desmarel Mallorca, and yours truly, Micaela Pangan. In this study, we focus on improving energy efficiency in mechanical manufacturing systems. Energy efficiency means using less power to do the same or even more work. It is one of the main goals in modern manufacturing because it helps save resources, lowers production costs, and protects the environment. Mechanical engineers play a very important role in this. They are responsible for designing, improving, and maintaining machines and systems that make production faster and more effective while using less energy. Their job is not just about building machines that work, but about making sure those machines work efficiently and sustainably. In today's world, industries are shifting toward sustainable development. This means that businesses are finding ways to grow without causing harm to the planet. Because of this, energy efficient manufacturing has become one of the key focuses in mechanical engineering. These studies this study reviews different research papers and studies from the year 2000 up to 2025. By looking back at what researchers have done during this time, we can understand how energy efficient systems were developed, what improvements were made, and how these methods are applied in real-world manufacturing. For the statement of the problem, manufacturing industries are known for using huge amounts of energy. Every day, factories around the world consume electricity and fuel to power their machines and equipment. This high energy use also produces large amounts of emissions that harm the environment. Even though many researchers have already studied ways to save energy, there is still no complete summary that combines all of these findings. There isn't a single study that clearly shows how energy saving practices have evolved, which methods became the most effective, and which technologies have helped industries reduce their energy use. This gap makes it difficult for engineers and researchers to fully understand how far we've come in improving energy efficiency. That is why this study focuses on answering one main question: how have energy efficient manufacturing practices in mechanical engineering developed and changed from the year 2000 to 2025? By answering this question, the study can help show the progress made over the years and highlight the areas that still need improvement or innovation. The main goal or general objective of this study is to analyze the development of energy efficient manufacturing practices from 2000 to 2025. To achieve that, there are four specific objectives. First, to identify the major energy saving practices used in mechanical manufacturing systems. This means looking at the different methods and strategies industries have used to cut down energy use. Second, to trace how these practices have changed or improved through the years. For example, we look at how technology and design methods evolved to make machines and processes more efficient. Third, to discuss the key technologies and methods that help increase energy efficiency in mechanical engineering. This could include automation, new materials, or better production systems. And lastly, to identify the challenges and research gaps that remain today. These are the areas where more study and innovation are still needed. By meeting these objectives, the study can give a clear picture of how energy efficient manufacturing has developed and how it can continue to improve in the future. This study is very important because it gives a clear understanding of how energy efficient manufacturing has improved through the years. It helps us to see what technologies and methods are most effective in saving energy and improving production. For students, this study provides useful knowledge about how mechanical engineering contributes to sustainability. for engineers and researchers, it can serve as a guide for designing better systems and solutions that use less energy but still perform well. The study also supports the global goal of building industries that are more sustainable and environmentally friendly. When industries save energy, they also reduce pollution and lower their costs. This not only benefits companies but also helps protect the planet. In short, this study shows how mechanical engineering continues to innovate not only to make production faster and better, but also to make it more responsible and sustainable for future generations. This research focuses only on reviewing and analyzing existing literature from the years 2000 to 2025. It gathers information from published studies, reports, and academic papers about energy efficient manufacturing and mechanical engineering. The study does not include any new experiments or actual data collection. Instead, it summarizes what has already been studied by other researchers. The goal is to organize this information and highlight the progress, patterns, and trends that have shaped energy efficient manufacturing over time. This study can serve as a helpful guide for students, engineers, and researchers who want to develop a new systems or strategies to save more energy. However, because it only depends on available research, it is limited to what has already been published before 2025. Any new developments, discoveries, or technologies that came after that year are not part of the study.
So I'll be discussing the summary of the reviewed literature about the role of mechanical engineering in promoting sustainability. So the studies emphasize that mechanical engineers play a vital role in achieving this SDG or the Sustainable Development Goals, especially by creating technologies that support sustainable growth. So sustainable engineering integrates environmental, economic, and social goals into design and manufacturing, ensuring that engineering solutions meet both industrial and environmental needs. So the literature highlights energy efficient systems that combine renewable energy sources such as smart controls and energy recovery methods to reduce emissions and energy waste. It points out as well that the importance of green design principles in engineering education, which help train future engineers to be more environmentally responsible. In addition to this, smart manufacturing technologies such as the internet, artificial intelligence, and digital twin are used to monitor and optimize energy use in real time. So, overall, the reviewed studies show that mechanical engineering links technological innovation with sustainability, leading industries toward cleaner, smarter, and more efficient production systems.
Chapter 3 explains the theories that support the study on energy efficient manufacturing and mechanical engineering. It shows how sustainability and innovation guide modern production. It begins with sustainable development, which focuses on meeting present needs while protecting resources for the future. Eco efficiency follows, which stresses higher productivity with fewer resources and less waste. Industrial ecology compares industries to natural ecosystems, where waste from one process becomes useful for another process. Cleaner production promotes preventing pollution through better design and efficient technology instead of dealing with the waste afterwards. And lastly, the circular economy highlights keeping materials in use through reuse and recycle to cut energy use and waste. Together, these theories explain how mechanical engineers can improve manufacturing efficiency while protecting the environment and supporting long-term sustainability.
Good day everyone, my name is Patricia Nicole and today I'll briefly explain how we conducted a review of energy efficiency of manufacturing and mechanical engineering over the last 25 years. Our approach was a qualitative systematic literature review, a structured process to ensure accuracy and minimal bias. We focus on the years 2000 to 2025 to capture long-term trends. Our topic was specific: energy efficiency manufacturing, ensuring relevance and depth. We used trusted secondary sources like journals, books, and conferences papers. The main databases were Science Direct and Google Scholar. Following the flowchart here, we applied strict inclusion and exclusion criteria to filter out irrelevant studies, keeping only high-quality papers for review. Next, we did a content analysis to find recurring themes across the literature. Four key areas emerged: optimization, improving processes and energy efficiency; renewable integration, using solar, wind, and geothermal power; automation, smart machines, and AI to reduce waste; material efficiency, lightweight materials, and waste reduction. All sources were cross-checked for accuracy, and we follow strict ethical guidelines ensuring proper citations and proper reporting.